Right, good day, Matric AP students. We are doing finding the Z values given the area probability. We're working with normal distributions. You're going to need your table and you're going to need these notes. Okay, and there's all kinds of things going on here, violin lessons in the background. And helping us today, we have Boati. So hello, Boati. Yes, so come in specially. And we have Daniela. Hello. And we have our cool and composed Henna. Right. Thank you to those three for coming in. Okay. Right. And let's share our screen. And ka-ching. Okie dokie. So up to now, we've been given the Z scores. Okay, and we found the area. Remember, the area, okay, is equal to, in normal distribution, the key ideas are if you've got a normal distribution and you've got your Z scores, remember your mu for Z is 0, that's 0 standard deviations away, so that's your mean. Okay, 0.5, the area is the probability. So to the right is 0.5, to the left of the mean is 0.5. The total area is 1. And don't forget that we use symmetry all the time. Okay, but now we're going to be given the area, and then we're going to be asked to find the Z score that produces a certain area. And then later on, we're going to have to find the X score, okay, given an area. Right. So we start off just getting used to using the table. And again, for all of these, I would always draw a diagram. Okay, they give you a shortcut later on in the textbook. I don't believe in shortcuts for this. If you don't draw a diagram, you tend to make mistakes. Right, so let's have a look. So remember now your probability, okay, when they talk about Z is greater than or equal to A, but what they mean by A is equal to the specific, you can use any notation you like, but A is your specific Z score that we're working with. So A is actually a Z score, right? So they want to know what's the Z score such that the area if is going to be equal to 0.3015, the area which is bigger than that particular Z score. So if we have our diagram for A, okay, and we're not working with X scores, so we don't have to worry about that, but I've got my Z scores, mu is 0, okay, and then I want to know the area that's bigger than A must be 0.3. So A must be here because this whole area to the right is 0.5, but we want the area. So A is some Z score, and we want this area over here. So this area here is 0.3015. So that's the area we're given, and you want to know what the Z score is. What's that Z score? So that you get that area to the right of it being 0.3015. Now remember, the table reads off the area is between 0 and a particular Z score. Okay, between 0 and your Z score. So the table, these are your areas over here. Okay, your table works with that. Those are your areas, right? So we need your table will give us this area. Okay, so in other words, the probability that Z, okay, this is still for A, lies between 0 and A will be equal to, so this will be the H of Z score I'm looking for, 0.5 minus 0.3015, which is going to be equal to, okay, 0.5 minus 0.3015. So that area over there is 0.1985. So that is the area. This area here is 0.1985 because they've got to add up to 0.5. So this area here in pink is 0.1985. So that is what our table is going to. So we're going to look up on our Z score table. So H of A is equal to 0.1985. So now I go to my table and I try to find here my areas, and I'm looking for it. They go in order, right? So 0.1985 is over here. And what's the associated z-score? It's 0.52. Okay, so 0.52, so just over half a step. So A must be equal to 0.52. So this value here is your z-score that we're looking for is 0.52. So if you go just over half a standard deviation away, okay, then that area will be 30%, okay, of your data. Okay, so that's equal to that. And let me check out, right? Indeed, I am correct. Okay, right. Let's have who are we going to have? Daniela. Okay, Daniela will come in to the sum, and there she is. Oh no, she said she's uncomfortable. Right, we'll send her back. Right, she'll just shout from here. You know that Daniela always shouting. Right, B. Right, we need to go draw your picture for B. So B says, what is the probability that Z is greater than A, that the area after A will be 0.8910. So let's think about this. So I want my area that's bigger than A. So we're working with just Z scores. Mu is 0. Okay. To be 0.8910. So this whole area is 1. So A, the Z score of A, must be somewhere there. And then this area over here is going to be equal to that area in there. Okay, because that is your probability that Z is greater than A is equal to 0.8910. Okay, so how are we going to use that? Well, that whole area is 0.8. The whole green area is 0.891 area, 8910. And then this specific area here to the right of the mean is 0.5. Okay, and the whole thing is 0.8910. Then this area over here must be equal to, so the probability that Z, again, if you don't quite get this notation right, it's not the end of the world, is less than 0 and greater than A, remember this is a negative value, okay, must be equal to that whole thing, which is 0.8910, chop out that 0.5, and I'm going to get 0.8910 minus 0.5 is 0.3910. So that is this area over here. Okay, that area surrounded by the pink is 0.3910. Okay, so that's 0.3910. So remember, if A was positive, that same area would be 0.3910. So this area here is also 0.310. Okay, so that's the absolute value of A, or positive A if you want to think of it like that. So I'm going to just look up, okay, on the table, I'm going to look up H of, we know that H of A is 0.3910. So I'm going to go look up 0.3910 in the table, and 0.3910, well, it's close to 0.3907. Okay, and that's going to be then, that, I mean, it's pretty close. 0.3910 is just a little bit to the right. It's not in the middle. We'll deal with the case where if it's right in the middle, okay, what do you do? So it's going to be, that's in line with 1.2. So it's going to be 1.23. But now remember, so that, okay, implies A is equal to, but that's actually for A is equal to 1.23 is over there. So this must be to the left using symmetry. So that must be negative 1.23. So A, okay, that's 1.23 to the right of the mean, but this is to the left, but the same area, so the same distance away. So A is equal to negative 1.23. Okay, and if I look and check my solutions, pain in the bum if you're wrong, but Daniela, you have helped me to get the correct answer. The South never lets you down. Right, okay. that is B. Right. Let's try sneak in C over here. Okay, and C says, what is the probability that Z is less than A is equal to 0.1419? Okay, right. So again, guys, you need to get your diagram correct. If you get your diagram right, I think it's easy. So 0.1419, that area to the left, let's think about it. Okay, I've got a Z score. Here's a Z score of 0. If I want the area to be to the left, if I put an A over here, then that area will be way more than to the left, would be way bigger than 0.5. At this point to the left would be 0.5. So to get an area to the left, because it's less than, okay, so we want the area to the left of A. So once again, A is going to be a negative number, okay, because it's to the left of the mean. So this area over here, to the left of A, the area under that curve must be equal to 0.14. So that area there is 0.1419. Okay, right. So Boati, hey, you're going to look up, be careful. So this area here is also 0.1419 because of symmetry. And you want this area in pink over here. And how are you going to find that area? Okay, well, the area between A and 0, okay, so the probability, again, you don't have to write this in, Z, like, guys, you can always just fill things in your diagram, that Z is bigger than A and less than 0 must be equal to 0.5 minus 0.1419, okay, and if we get our calculator, what do you get, Barty? 0.5 minus 0.1419, and we get 0.3581. 0.3581. So this area in pink here is 0.3581. So I'm going to look up that probability over there of 0.3581. Okay, that'll give us this score over here. That's the positive value of A, and then we just make it negative. So if I go to my table and I look for an area of 0.3581, did we say? 3577 is over there, and that's 3581 is pretty close to that. It's pretty far from 3599, so we can go with that one over there, which is going to be 1.07. So 1.07 is your score for A, but it's so that is 1.07 over there. So ours is going to be the negative. So A is going to be equal to negative 1.07. That's the score we're looking at. To the left of that Z score, remember A is a Z score, to the left, okay, will be an area of, just over 1 standard deviation to the left will be an area of 0.1419. So let's just check, and we get negative 1.07. I'm doing amazingly well today. Okay, all right. Well, actually I shouldn't say that. Buati, you're doing amazingly well. Right, let's get our Zen child, Henna, to do question D for us. And question D says, go work out the probability that Z, what is it with the suburbs and mowing lawns? Flippin' hell. Everyone's always mowing or weed eating. Okay. Probability of Z less than A is equal to 0.9670. So we need to draw a diagram. Remember, this is an area under a curve, and the maximum area is 1 under a normal distribution, well, because it's the probability. Okay. And now there's a Z score of 0. Now I want our area to the left. Okay, the area to the left here is 0.5. Ours has got to be bigger than that. Okay, we want 96.7% of our data to be to the left of that. So A is going to be quite far to the right here. Okay, so this area in yellow over here, this whole area here, is that area there is 0.9670, right? But our table only deals with the area surrounded in green here. So what area, how are we going to figure out that? Well, this bit over here is 0.5. So the probability that Z is bigger than 0 and less than whatever that Z score is, A, okay, must be equal to it's going to be the whole thing, chop out 0.5. So 0.9670, chop out 0.5. Okay, 0.5, and we get 0.4670. Okay, plus 0.5, yeah, that's right. So this area in green is 0.4670. Okay, so in other words, okay, H of whatever A is equal to 0.4670. So now I'm going to go to my table and look up 0.4670. And an area of 0.4670 is pretty darn close to 0.4671. Okay, so it's going to be 1.84. Okay, 1.84. So A is equal to 1.84. That Z score there is 1.84. So if you have a Z score of 1.84, so if you're nearly 2 standard deviations to the right of the mean, okay, then you're going to have 96.7% probability of things being to the left of that particular score. So we get 1.84. Okay, let's see if we have to throw Hannah out the window. Did she get one? Is 1.84 the right answer? Yes, it is. Congratulations, Hannah. Right. That is example 4 done. Lovely stuff. Okay. Righty. Okay, I hope you managed to get most of that done. Okay. Right. So, example 5. Okay, now, okay, we're dealing with X scores as well as Z scores. Again, your diagram is key. And Boati has put up her hand. She's super keen. Hello, Boati. There's Boati's eye. Okay, she's going to come and help us with the sum over here. So it says, the marks on a university physics exam was found to be normally distributed with a mean of 52. So your mean, let's just summarize it, is equal to 52. And standard deviation, always check, be careful that's not variance that they give you, is 17.5. All right. It says, what is the minimum mark a student has to achieve to be in the top 1%? Okay, so to be in the top 1%, it's a normally distributed. Okay. Right, I'm going to start with Z here and work with X underneath in this case. Okay, so Z is naught is over there. And in the top 1% means the probability of it being bigger than that specific. So let's call that Z score over here A. Okay, and the probability that it's in the top 1%, there's that area over there. Okay, so this area here, okay, we want to look for the mark so that the probability of you being in that area is equal to 1%. Okay, and 1% is 0.01. So this area over here is equal to 0.01. Right. So that's our first thing over there. So the first thing we're going to find is we're going to find the Z score that creates that, and then we're going to find the specific X score that creates it, the actual mark that will lead that you need in order to be the bottom score. Okay, this is the bottom score in the top 1%. Okay, right. So what area would we have to work with? Well, the table can't give us this, but the table can give us this green bit over here. Okay, and that is going to be equal. This whole thing is 0.5. So that the probability that Z is bigger than 0, less than A, we want that green area to be 0.5 minus 0.01, which is equal to 0.49. So that area over there is 0.49. So that's the area we're going to look up. We're going to look up an area of 0.49 on our table. Okay, that's your probability that we're working with. So if I go to 0.49, an area of 0.49, it's 0.489, 0.4901. Okay, I would go with that one over there, which is 0.4901, yeah, which is 2.33. Okay, it looks like to me, double check that, yeah. Okay, so the Z score that produces that area is going to be 2.33. So this z score over here is 2,33. So we know that A, don't forget A is just a z score, is equal to 2,33. So now I've got a z score. Okay, I've got a z score of 2,33. Okay, that'll be the minimum z score so that the area to the right is 1%. Okay, now I need to find what that is as an x score. And what links up x and z? It's the formula x is equal to z minus mu over sigma, right? If I manipulate that formula, I'm going to get, I'm going to crack, z is equal to, what? I can't believe you did that. X minus mu over sigma. So I get z times sigma, shame on you, Walter, plus mu is equal to x, because I'm looking for an x score. What is my z score? It's 2,33. So 2,33 times sigma, which is 17,5. 2,33 times 17,5. Okay, plus mu, which is 52, and that's going to be our x score. And if I use my calculator, because I'm not a genius, I'm going to go 2.33 times 17.5 plus 52, which is exactly what Boati got. She got an answer of 92. So x is equal to 92,775, right? And what was that? That was the mark you needed to be in the top 1%. So your minimum mark would be approximately 93%. Okay, so is the minimum mark that you need to be in the top 1%. Okay, and a lot of entrance exams work like this. Okay, they want the top 1% for a particular test, and so it's not a fixed mark. Okay, it varies from year to year. Okay, so your process, if you're given an area, if you're given a probability, what's the probability? It's an area. Okay, draw your diagram, get the z score, then use the formula z is equal to x minus mu over sigma, manipulate it, okay, and get the x score that goes with it. Right. B. Okay, last one. It says, if it is known that 25% of the class failed the exam, find the pass mark. So first of all, we're still working with mu is 52 and sigma is 17,5. Okay, all right. And now, if I draw my diagram, remember we start off, if you're given areas, we start off with z scores at the top. So z is 0, and then I'm going to worry about the x scores later. And I know 25% failed. So some mark over there, a z score of A is going to be your failure mark, right? And to the left of that, within that region, 25% of the class have to fall. So that area over there in yellow is 25%. In other words, 0.25. Okay, so we want the probability that Z is less than A to be equal to 0.25. But to do that, I've got to, the table can't deal with that. The table can find us the pink area though. And then I'm going to use symmetry. So the table can deal, and to get that, well, the probability that the Z score is bigger than A and less than 0, so in other words, a pink region, well, that whole area is 0.5, so it's going to be 0.5 minus 0.25, which is equal to 0.25, so that area there is 0.25, 0.25 plus 0.25 is 0.5. Right, so it happens to be the same in this case. So I'm going to look up a Z score, an area of, I want an area of 0.25. Okay, so I'm going to go to your table, I'll try to find that. And I think this is one where it's kind of pretty much smack in the middle. Okay, so 0.25 is between, there's 0.2486, so 0.25 is almost right in the middle. Up to now, they've all been pretty much closer to one side than the other, but 0.25, well, it's 14 across to there, or 0.014, and 0.2, and another about 17 to the right to get to 0.2517. So in this case, 0.25 is almost smack in the middle, okay, of those two things. Okay, up to now they've always been very close to the one or the other, but 0.25 is in the middle. It's 14 above, 0.014 I should say above 2.486, and it's 17 below that, so it's pretty much in the middle. So what do we do? Well, we say, okay, well, this score over here goes with 0.67, okay, and this score over here goes with 0.68, so it's halfway between, okay, 0.67. What's halfway between 0.67 and 0.68? Well, it's going to be 0.675. So that's what I'm going to use as my Z-score, 0.675. So only when it's roughly pretty much in the middle, okay, then we're going to go and kind of take the middle point of those two things. So I'm going to use a Z-score of 0.6. It's funny me. 0.675. So Z, so I'm going to use A is equal to 0.675. Okay, so A is equal to 0.675. That's the thing I'm going to use for my Z score, but ours is to the left, so that's where 0.675 is. Ours is to the left, so I'm going to use negative 0.675. That's going to be the Z score I'm going to work with. Okay, I'm going to work with that is equal to negative 0.675. Right. So that is your Z score, but I need the X score. In other words, the actual mark. So I'm working with a Z score. A is equal to negative, don't forget the negative, 0.675. And I know that Z is equal to X minus mu over sigma. If I manipulate, I get Z times sigma plus mu is equal to X. My Z score is negative 0.675. Sigma is 17.5. And the average was 52. Okay, so if I want 25% of the class to fail, then the fail mark must be equal to negative 0.675. Negative 0.675 times 17.5 plus 52. Voila. And we get 40.18. So X is equal to 40.18%. So your fail mark is going to be approximately 40%. Anyone who gets 40% or below, okay, unlucky, they fail. All right. Okay, guys. Thank you very much for that. Thank you to our three helpers, Henna and Boati and Daniela. I want you to try do example 6 on your own. Okay, don't just read it. Go try to do it. Check your answer in the textbook. Okay, and in the second half of the lesson, we'll go live some homework exercise 2 on page 185. I hope this is all making some kind of sense, and I hope life is going well inside your houses. Okay, guys, take care. Arrivederci.